Hi guys, Russ here from Wilson Land and Cattle Company. We're working on our piston pump, and today we're going to be hooking the batteries up. We had a hard time getting our batteries. We got four 12-volt batteries, 115 amps a piece, and we need to hook them up 24 volts. So I'm going to show you how to hook them up in series and parallel so you get complete charge and complete discharge. These here are our batteries. We got four of them. I got the brackets made for them to hold them in. We want to hold them in place so they don't get shifted around. Then we got to hook our terminals on there. To hook the batteries up in series and parallel, they need to be hooked up in a specific way in order to get complete charge and complete discharge. Here's the drawing that I drew up. And a lot of times, I know in a previous video I said I don't use blueprints or drawings, but I do for electrical systems because it's very easy to get a wire screwed up. Okay, we need to hook them up in series. I put a dotted line around, so we're going to hook these two 12-volt batteries together to make 24 volts, and then these two batteries here together to make 24 volts. And that's hooking in series, and then we'll hook them in parallel to get our amperage. So to hook them in series, we just have to hook the positive to the negative on both sets of batteries. And then we hook to go parallel with it. We go negative to negative, positive to positive. And then we have a terminals, our terminals that come off of the batteries, we hook to this positive and we hook to this negative. And that will get our full discharge and our full charge. And these terminal wires will come back to our charge controller. It's going to be charged with solar system, and we'll be hooking that up in another video. And then we have to run our wires to our pump motor. We have 115 amp batteries. So we hook those two batteries together in parallel, or those two sets of 24. This is 24 volt and this here is going to be 24 volt. We hook them together parallel. That gives us 230 amps. Our motor draws 20 amps. At 230 amps, we should be able to run that motor for 11.5 hours. And it's going to pump. We tested it at 15 gallons per minute. But I'm going to be conservative and say that the the pump's going to be able to pump 10 gallons per minute. So at 10 gallons per minute, I need at least 700 gallons of water per day, depending on how hot or cold it is during the day. It could go up as far as 1,000 gallons and as down as low as 500 gallons. It's just depending on the day. That 11.5 hours, our pump will need to run for at 10 gallons per minute. We'll need to be able to run it. At the most, we'll need to run it 100 minutes per day, enough for almost 7 days if we were not to charge these. So if we had a couple days with really cloudy and the solar panels aren't working quite the way they should, we have a backup on our reserve capacity on our batteries. Let's go ahead and get these batteries secured in, and then we're going to make the terminals for it. And I don't like how that is going to be on there, so we're going to have to do something different. Okay, got them secured in there. They're going to be, those are pretty secure, so we need to go from here to here, and here to here, and then from here, let me get my drawing. Okay, so we have our drawing. We want to go from here to here, and then from here to here, and then from this one to this one, and this one to this one. That'll be pretty easy, right? Nothing's easy sometimes. So let's see. I bought this. This is a battery terminal. It's the longest one I could get. So hopefully I have enough material here to use to make battery terminals for this thing. You want your terminal wires as close or as straight as possible, but you want to leave your caps open for your batteries. I don't have a crimp tool for these, so we have to improvise on that as well. Let me mark this. That way we'll know how long to make both our terminals, and that's not marking well. I have an idea how we're going to do these. Cut our cable. Okay, let's go in the shop here and see what we can come up with. I apologize for the lighting in this shop. It's not the best. This here will be a good thickness, I think. Okay, so I'm going to take this over on the bandsaw and just cut a little chunk off of it. And then we're going to drill a hole in it and take the grinder, cut a slot in it. Okay, this bit here looks pretty close. It's a little bit smaller, but I think we can grind that out. Put our hole about there, and it's not centering a piece of metal, so we'll put it center. Bring it down 5/8 of an inch. So right there. Go over to the press. Something like that. I wanted a little bit wider to top. That way we were at a cutoff wheel, so I ordered some more. I really like these cutoff wheels from Benchmark Abrasives. They last pretty well for the money. Okay, I got a slot cut in there. See what it looks like. Looks pretty good. Okay, now I need to come up with some sort of a piece to go in there and crimp down on that. Something that looks like that, I guess. Let's see what it looks like when we get done cutting it. I'm gonna take this out and dunk it in water. Okay, we're gonna give her a shot, see what she turns out like. That's what we ended up with. Looks like a pretty good crimp to me. I'm happy with that. Yeah, there's my cheater. Pretty pleased with that. It's not perfect, but I'll tell you what, it sure is better than having to go buy a crimp tool for this. it'll get the job done. If you guys want to make one, that's kind of what it looks like. Not much to it. Does a really good job of crimping. I'm going to put it up here so the next time I need it, I won't remember where it's at. You don't run into that problem, do you? It happens to me quite a bit. Our leads that go back to our pump motor, our pressure switch and relay, and our solar charge controller are right here. Positive, negative. Well, let's go get (24.7.70). The batteries must be down a little bit, but we have our 24 volts. Okay, we need to check our relay to make sure we're wiring it up correctly. So what I need to do is check the continuity. Okay, our meter's working correctly. Okay, we don't have any continuity. I guess the white's neutral and the black's positive. Okay, we have continuity. Continuity's off. Okay, so this is our negative, this is our positive, and then this here's our switch that's going to actually go back in to turn our pump on. I can take this out to the pump or directly to the pump motor, but I didn't want to. We have positive and negative to the battery, and then we have positive and negative from the solar panel. And then that's this here little unit here is what's going to control the charging of the batteries from the solar panels. So that there's pretty cut and dry on how to hook it up. So I'm not going to do a dry wiring diagram on it. We're going to go into a pressure switch right here for our pump. So I need to figure out how we're going to do this. I guess for the lack of better words. Okay. Our relay is going to take a lot less amperage than what your motor is. So your relays are going to cause less spark and arcing in your pressure switch on these little points. There's little points in here. And actually there's just, whenever it's calling for water, those two sets of points come together, make contact, and then put electric to wherever it needs to be. So what we need to do is, I don't know how to do this neatly, but I'm going to try. One negative to the pressure switch. One positive to the pressure switch. Now I'm no electrician or no electrical engineer, so I don't know the drawings and all that jism that goes with it. So we need one negative to go to this relay. Okay, and we need one positive to go to this relay. Okay, so now this positive is going to fire two relays. It's going to turn it on and off. And then we have our negative. Which is going to fire two relays. Okay. to take a positive to the motor from the relay. Then we need to take a negative. Hey, Toby. Oh, Tessie. Hey, honey. What are you doing? Huh? What are you doing? Good girl. You're a good girl, huh? You just come to say hello. Yes, you did. That's a good girl. That's a good girl. Not the neatest drawing in the world, guys, but it will get the job done. Okay, now hopefully I can explain this to you. Okay, we have the battery bank, our motor, our pressure switch, and we're going to have 2 relays. We're using relays because it takes less amperage to set the relay off, and I don't want a lot of amperage going through our pressure switch. It'd probably be okay, but I'm just playing it safe. I'm going to do relays. Okay, so we have our battery bank. We need to run a positive and a negative to our pressure switch, and we need to run a positive and a negative to each relay. Okay, and then we have our positive and negative to each relay, and then we need to take this here's whenever the relay is closed, we're going to run a positive down to our motor, and then we're going to run a negative down to our motor. That way, whenever our pressure switch closes, it turns the relays on, which closes the switch, and in turn turns the motor on. So hopefully that makes sense to you. We're going to go ahead and get that wired up. We got our pump wired in. Got our batteries here. We got them. We made the terminals. And we have the hot wire going back to the relays and the pressure switch, and ultimately it goes to the motor. And there's the neutral wire. Everything's buckled in. We got the brackets. And then in here we have 2 relays, which goes back to the motor. This is a low pressure cutoff switch. So watch these little terminals in here. They're gonna touch. We hold that. The pump's running. We hold that until it gets pressure, and then it will go on its own. There you go, guys. That's wiring batteries in series and parallel, hooking the pressure switch up back to the DC motor for our solar pump. Please subscribe, like, comment, share with a friend, hit that notification bell. Check out our new merch store. I have a link in the description below. We'll talk to you later. So long.